All right, children. So very quickly in this video, I'm going to briefly go over x and y intercepts of quadratic functions. So in this first example here, we can easily get the x-intercepts of f of x by simply solving this standard form of quadratic, saying 0 equals x squared minus 2x minus 15. The reason for that is, I don't know, let's just say we had this right here, right? So we're looking for these. These are the x-intercepts that occur on the x-axis, right? And what's more, they occur where y is equal to 0, right? Hence the 0 that I placed in for y. Okay, so when I solve this standard form quadratic here, um, we'll know our x-intercepts, right? So really fast, I can just do filling in the blank here and just factor this. So x plus or minus something times x plus or minus something else. What are the factors of negative 15 that combine to give us negative 2? That, of course, is going to be negative 5 and positive 3. Negative 5 times positive 3 is negative 15. Negative 5 combines with positive 3 to give us the negative 2 that we need. Okay, this, of course, means that our x-intercepts must happen at negative 3 and at positive 5. Okay, and we know because our a term here is a positive 1, right? We could say this is a positive 1 here, that it opens upwards. And we know now where it's going to cross paths with the x-axis, namely at negative 3 and positive 5. Okay, our vertex, right? Well, we don't know that yet. We would have to complete the square. I can do that real fast. So that would be x minus 1 all squared minus 1, so minus 16. So at negative 1, way down here with, let's say, negative 16 is right there. So way down here. So our parabola is going to look something like that. Okay, and yeah. So then let's look at our next example here. Okay, so what we're going to want to do now is the exact same thing. Getting ahead of myself. I forgot this also includes the y-intercepts, right? Well, we know where the y-intercept is going to happen. It's going to happen right there at negative 15. Okay, and we know that because the y-intercept happens where x is 0, right? So simple concept there. If it's in standard form, you can rest assured that c is pretty much always your y-intercept. Okay, if it's in standard form. If it's not in standard form, not going to be so easy. Okay, so now let's move on to the next example. Okay, so this guy is not going to be so easily solved. Um, that said, I don't think it is. So that would be 46. Uh, yeah, no, that's not going to be so easily solved. We're going to have to either complete the square or use a quadratic formula. I'm going to complete the square just because the more examples of it that you see, hopefully, the less afraid of it you'll be. So set this equal to 0, 2x squared minus 12x plus 23. And of course, I want to complete the square with this guy here, right? And I don't want a to be anything but 1. I have an equation this time, so instead of factoring out the 2, I'm just going to divide everything by 2 because I can, because it's an equation. It's not necessarily just a function this time. So now I've just got 0 equals x squared minus 6x now plus 23 over 2. Now I can easily complete the square with this. X minus 3, because that's half of b, and then minus that all squared, plus 23 over 2. Right, I want to combine this minus 9 and plus 23 over 2 by simply saying, well, that can be just negative 18 over 2 plus 23 over 2. That's going to leave me with 5 over 2. Subtract that from both sides. I'm going to get x minus 3 all squared is equal to negative 5 over 2. Okay, and then take the square root of both sides, add 3 to both sides. X is equal to 3 plus or minus, and then we have something interesting happen here. After I do all the square rooting, right, I'm going to end up with I. Okay, and it's going to be plus or minus the square root of 10 over 2 times I. So I end up with a complex conjugate in this case, right? And what that's going to mean is simply that I don't have a real set of x-intercepts, right? And if we look at the graph, so let me erase and give myself some room here. But if we look at the graph of this, it's going to not touch the x-axis, okay? And that is a thing that happens. That just means that our x-intercepts are going to be imaginary, or complex rather. Okay, so if I back up, if I had done this into vertex form instead, I would have gotten that g of x is equal to 2 times x minus 3 all squared plus 5. Okay, so that means I'm shifted to the right by 3 and up by 5. And the 2 is positive, so obviously we're opening upwards, and we clearly see, right? We clearly see that we do not intersect the x-axis at all. So this just means no real x-intercepts. They're imaginary. It happens on another plane of existence, we'll say, right? And to find the y-intercepts, well, again, it's just as easy as looking at C. So our y-intercept happens way up here at y equals 23. Okay, so that's all I have for this video as far as quadratic x and y intercepts. If you have any other questions, shoot me an email or come and see me. Goodbye.